Okay, welcome back to Methods of Operations research course, and in this lecture we will be discussing the transshipment problem. The transshipment problem is a special type of transportation problem. Actually, we can formulate the transshipment problem as a transportation problem and solve it using the transportation simplex method. And in this lecture we will learn how to do it. First of all, what is the difference of the transshipment problem and what's its relation with the transportation problem? In the transportation problem, only direct shipments are allowed. If you remember our discussion of the transportation problem, there are a number of suppliers and there are a number of demand points, and you can ship from these suppliers to these demand points, and there's an associated cost for each one of these shipments. But it is direct shipment. You are sending from the supplier directly to the demand point. But sometimes you may have some intermediate or transient nodes between the supply and the demand points. Okay, what do we mean? You have this supplier, you have this demand point, again you may have this supplier, and in between them there can be another point in which these, instead of directly shipping to the demand points, these two suppliers send their units to this transshipment node, and then it will send it to the demand point. If we have such transient nodes or intermediate nodes, then the problem, we call it the transshipment model. Okay? But still, we can convert it to a regular transportation problem and solve the transportation simplex method. And why do we want to do it? Because the transportation simplex is an efficient method to solve these models. If we can formulate this problem as transportation, we can make use of that efficient solution procedure. Let me represent the transshipment problem in this figure. So here, as you can see, there are 1, 2, 3, 4, 7 nodes. So these are called nodes. Okay, and these numbers, values with an invert arrow, it means that it is the supply. So the supply amount in node P1 is 1000, and the supply amount in P2 is 1200. And an outwards arrow means it's a demand. And as you can see, the demand of this D1 is 800, demand of this D2 is 900, and demand of D3 is 500. Now, the directions of the arrows are important. As you can see here, we can ship from this P1, which has a supply amount, which is a supplier. We can ship from P1 to T1 or T2. And look at T1. What is it? It's a transient node. It doesn't have any supply. It doesn't have any demand. It just transfers what it gets from the suppliers to the demand points. Okay? And look at D3. D3 is a demand point in which it needs to receive 500. But it is different. D3 is different than D1 and D2. Why is that so? Look at D1. D1 has a demand value of 800. Okay? But at the same time, it can be used as a transient node because it can receive from T1, but it is also possible to send units to D2. What do I mean? In the optimal solution, for example, you can receive, this D1 can receive 1000 items. So 800 of these will be satisfied, will be used to satisfy its own demand, but 200 will be sent to D2. It is possible, such a solution is possible. But for D3, you see there is no other, nodes that it sends, it ships, it only receives. And the amount that it needs to receive is 500. Okay, look at this P1 and P2. They are only sending units outwards. They are not receiving anything. Okay, And look at T1. T1 doesn't have any supply or any demand. It just receives and sends. Of course, in a question, it could be something like this. T1 also has a supply value of 100. So what does it mean? It has 100 supply, it can receive from supply points, and it can send to other locations. It's also possible. But looking at this shape, looking at this figure, we can understand that there are different types of nodes in a transshipment problem. What are these different types? First of all, we have P1 and P2, which are pure supply nodes, that they only send, they only ship, they don't receive anything. Okay, these are called pure supply nodes. Look at D3. D3 only receives. It doesn't send anything outwards to another city, to another demand point. So it is called a pure demand node. Okay, we have pure supply nodes, pure demand nodes. And the others, look at the others, T1, T2, D1, D2. They may have their own supplies, their own demands. It's not important. Look, D1 has its own demand, D2 has its own demand. But the important thing about these T1, T2, D1, D2 is they can both receive and send. And if it is the case, both receive and send, we call them as transshipment nodes. Okay? And these nodes are the transshipment nodes for this example. So in any transshipment problem, we will have some pure supply nodes, we will have some pure demand nodes, and we will have transshipment nodes. Of course, in an example, you don't have any, let's say, pure demand point. It's possible. I mean, you will have only pure supply and transshipment nodes. Or in a problem, you can only have transshipment nodes. No pure supply, no pure demand. It's also possible. But these are all the possible categories of nodes in a transshipment problem. Okay, it's important to understand or differentiate between these pure supply, pure demand, and transshipment nodes, because when we convert this problem into a transportation problem, we will be making use of these. Let's see how to convert a transshipment problem to a regular transportation problem. For our example, in this transportation problem, we will have 6 sources. Why is it 6? Because of this. These P1 and P2 are pure supply points. So we write all pure supply points as a source. But plus, we include the transshipment nodes as supply nodes or as sources. So pure supply plus transshipment nodes, they will be your sources. So in your transportation tableau, remember, you will have rows and columns, and the rows will be your sources. So you will have your P1 as pure supply, P2 as pure supply, and then T1, T2, and D1, D2. You will list them as also sources, but the thing is, they are transshipment nodes. Okay. What about the demand points? For the demand points, remember D3 is the pure demand point, pure demand. And what about this? They are the transshipment ones. So what is the critical thing is, we are listing these transshipment points as sources as well as destinations. So here I can write D3 as the pure demand point, and then T1, T2, D1, and D2 as the transshipment nodes. Look, these T1, T2, D1, D2 appear as column as well as nodes. Okay? And then, of course, in this transportation tableau, I need to write the supply values to the right-hand side, and I need to write the costs of shipping the items from these points, supply points or sources to destinations, to the upper right triangle. So let's discuss this, what we should write to these values as these values. Okay, so there is this simple procedure that you need to follow when you are writing the supply and the demand values. If it is a pure supply point, so in this table here, P1 was a pure supply point, right? So the supply amount that you are going to write here will be its original supply. Remember, in our example it was 1000. You will write original supply to here. Again, P2, it is 1200. Okay? You write the original value. For a demand of a pure demand node, so remember D3 was a pure demand node, and the demand of this one will be its original demand, and in the given example it's 500. Okay, so for this one they are easy. Write the original values. But remember, we have T1 over here as a transshipment node, and T1, T2, D1, D2 also, they are transshipment nodes. For these transshipment nodes, what do we write? Okay, as the supply value of a transshipment node, we write the original supply at this transshipment node plus a buffer amount. Okay, we don't know what is this buffer amount. In a few minutes we will discuss it. But what do? We write the original supply. For example, if T1 is this transshipment node that it receives P1 and P2, in our example it was like this. We didn't have any supply of that one. In this case, if the supply is 0, it will be just the buffer amount. But if this T1 also has its own supply, then it will be 100 original supply plus its buffer amount. Okay, and then for the demand of a transshipment node, so consider again T1 as a demand point. So what we are going to write here, we will write the original demand of this T1. In our example, T1 didn't have any original demand. But if you remember, our D1 had such a demand. And then we will be writing original demand plus this buffer. Now, let's discuss the buffer. The buffer amount, we will name it as B. Let's name it as B. It should be sufficiently large to allow all the original supply or demand units to pass through these transshipment nodes. So remember, this is T1 and it's connected to these supply points P1 and P2, and the supply amount here was 1000 and supply amount here was 1200. Okay, of course there's another transshipment point T2. We don't know initially how many units this P1 sends to T1 and P1 sends to T2. We don't know it, but still we can make use of or we can let's say assume that all of these supply will go through T1 and distributed to the demand points. So the buffer amount at T1 should be sufficient so that all this supply can pass through T1. Okay, then what do we write as the buffer amount? It will be the amount of total supply. But the thing is, since in a transportation problem it should be balanced, then total supply is equal to total demand. So what do we mean? The buffer amount is equal to either this total supply or to this total demand. And in our example, what is the total supply? It's 1000 plus 1200. This is the total supply. What about total demand? It is 800 plus 900 plus 500. Again, since it is balanced, this total supply is equal to total demand. And the buffer amount that we need to write is 2200. So let me explain it for our example. So what do? We write our original supply points P1, P2, and the supply values for them are equal to their original supplies. Then we list the transshipment points, and for them we need to write the original supply, which are 0 plus buffer amount. Original supply plus buffer. Original supply plus buffer. And these buffers over here are equal to, you can write 2200 because it is equal to the total supply. Then for the demands, for these transshipment points, the demands, what do we write? For T1, original demand is 0, so we only write the buffer. For T2, it is only buffer, there is no demand. But for D1, the demand is 800. So we write 800 plus B. And for D2, again, it will be 900 plus B, and this B, we will write the sum of all supplies. And for D3, this is a pure demand point, so we just write 500 here. Okay, so now this is the transportation problem, and look, the costs associated with this one. These costs are given in the problem. But what about this P1 to D1? Actually, if you remember our original shape or figure, P1 is connected to T1 and T2. And it is not, there is no way to connect P1 to D1, direct connection between them. Therefore, we are writing there M value, okay? M. And so for all arcs that does not exist in the figure, we write the cost as being M. What about the cost of sending units from T1 to T1? It is 0. What does it mean, sending from T1 to T1? Actually, there is no transfer there. It means there is no transfer. It's itself, T1, T1. Similarly, T2, T2, D1, D1, and D2, D2. For transshipment points, such courses or such costs are 0. So let me repeat, these values over here, 3, 4, and etc. are given in the question, in the example. These M values, we write them to prevent any transfer between indirect arcs, and these zeros for the transshipment ones. So this is how we convert the problem to transportation, and then we just use the regular transportation simplex method to solve it. And this is the solution when you do it. Use transportation simplex to the previous tableau, and you will obtain this solution. What does it mean? P1 sends 1000 items to T2. P2 sends 1200 to T1. So this T2 as a transshipment point, what it receives, it sends. 1000 receives, 1000 sends to D2. T1 also receives 1200 and sends that 1200. 800 to D1, and this 800 is used to satisfy its own demand. So D2, it receives 1400. 900 of this is used to satisfy its own demand, and this 500 is sent to the third D3, third demand point, and it will be used to satisfy its demand. So this is the optimal solution that we obtain by using the transportation simplex method. So of course, in order to solve this problem using the transportation simplex method, it should be balanced. In the regular transportation problem, the balanced problem is defined as if the total supply is equal to total demand, we call it a balanced transportation problem. Then the same definition applies to the transshipment problem. If the total supply is equal to total demand, then it is balanced. And in the original example, this problem is also balanced. Therefore, actually we didn't check it, but we need to check if it is balanced or not. So in the original problem, this was 1000. So the total supply inward arrows is 2200, and total demand, if you look, again the sum of them is 2200. So the original problem was balanced. But what happens if it is not balanced? Assume that instead of having 1000 supply at P1, now we have 800 supply at P1. How do we balance it? Again, remember from the transportation problem, we balance it using or adding dummy supply points or dummy demand points. Now, how do we do this? Again, look, total supply, it is 2000 and total demand 2200. So it is not balanced and there is a lack of 200 units of supply. Actually, this problem becomes infeasible because total supply is not satisfactory for the total demand. But in some cases, as we discussed, with a penalty, by giving a penalty, it is possible not to supply the total demand. If that is the case, then we can include a dummy supply point, okay? Dummy supply. And the amount of supply is this one will be equal to the difference between total demand and total supply. And then we need to connect this dummy supply with which of these nodes in the network. Should I connect, for example, it with P1 or, for example, T1? It's an important decision. And actually what do we do is we connect these dummy supply points to the demand points or to the nodes that have a demand. For example, D1. D1 is a transshipment point, but it has its own demand. So we connect it and we write its cost as being 0. Okay. Then D2 also has its own demand. We connect it with 0. And also D3 is a pure demand point. We connect it with 0. So these numbers over here, as we said, they are the costs of sending one unit item from one node to another. Okay, by this way we have this dummy supply point and we balance it. And now when we construct the transportation tableau, we include P1, P2 as being pure supply points, and also this dummy supply, it is also a pure supply point, and we write their supply values as 800 for this example, 1200 and 200. Okay, then we list the transshipment nodes, and these are the number of rows, and then we list the transshipment nodes. The order is not important actually, you can list them in any order, and then the pure demand point and write their their demand values. Okay, this is how we balance if the supply is less than the demand. Now consider the opposite. If the supply is more than demand, what do we do? So again, this time assume the demand of P1 is 1200. So in total we have 2400 of supply and 2200 of demand. So supply is larger than demand, greater than demand. What do we do in this case? Similar to the regular transportation problem, we need to include a dummy demand point. Okay, this time dummy demand. And what is the demand value of this one? It is equal to the difference, which is 200. And now which one should I connect to this dummy demand point? T1, D1, which one? I need to connect any node with a supply. Any node with a supply to this dummy demand point. So in this example, I have only these two supply points, P1 and P2, and their associated cost will be 0. By the way, in the previous example, if there is a penalty cost of not satisfying a demand, then the costs associated with the dummy supply point will not be 0, but it will be equal to the penalty cost. Okay? For this example, since we are not sending these items to dummy demand in real life, the cost is usually assumed to be 0. Okay, so this is how we balance when the supply is larger than demand. This is another example So our original problem can be like this. Okay, so we have 1000 supply here, 1200 supply here, and 200 supply at this T1. And the total supply, if we add up these values, again it will be equal to 2400. And the total demand, when we add up these, it will be 2200. And total supply is larger than total demand. So it is not balanced. And in order to balance it, similar to the previous case, I need to add this dummy demand point. And the demand at this dummy demand will be equal to the difference. And then, which nodes should I connect to this dummy demand? Again, let me repeat. We have to connect all the nodes with a supply value, not pure supply points, not transshipment points. The nodes which have their own supply, we need to connect it to the dummy demand. So this P1 has a supply, so we connect it. P2 has a supply, we connect it. But T1 also has a supply, then we also connect it with a cost of 0. So for this example, what do we write? So we write this pure supply point P1 in our transportation tableau. Okay. Then we write P2. Then we write T1, T2, D1 and D2. These are the supply points. What about the demand points? T1, T2, D1, D2, D3 and also this dummy demand point. Okay. And this dummy demand point is actually a pure demand point if you see, and we write 200 for the dummy demand. And for D3 it is pure demand point, it's 500. P1 it's pure supply, P2 it's pure supply. What about T1? T1 is a transshipment point and the supply here will be the buffer plus its own supply. What about T2? It's a transshipment point and it will be only the buffer. What about D1? D1 is a transshipment point, doesn't have any supply, it is only B. D2, it's a pure supply, it will be only B. What about T1? T1 is a transshipment point, doesn't have any demand, so it will be only the buffer. What about T2? Again, there is no demand, only the buffer. D1, it has a demand of 800, so it will be buffer plus its own demand. What about D2? Again, it is buffer plus its own demand. So this will be the transportation tableau corresponding to this example. And the costs, how do we write the costs? P1 to T1, the cost is 3. So we write 3 here. P1 to T2, the cost is 4. What about P1 to D1? There is no direct connection to D1, so it will be M. What about D2? It's also M. D3, it's also M. What about dummy demand point? It is 0. Okay, so similarly, we fill in all the costs associated with these ones. So please complete this example by yourself. Complete the final transportation tableau to this problem. Also, try to solve it using the transportation simplex method. It will be a good practice for you. So this is the end of our discussion for the transshipment problem.